All right, so we've seen what parametric equations are, and we've used the calculator and a table of values to graph them. Now the next thing would be finding intercepts using parametric equations. All right, so what you'll find is many times with parametric equations, things that maybe used to be done in one step, right, when we had regular function notation, will now take an additional step. But generally, the rules don't change, right? So still, a y-intercept is still going to be the value of y when x equals 0, right? So the first thing you're going to do is let x equal 0, right? So if you set x equal to 0, our x equation was, what was it, 1 minus t, I believe? X equals 1 minus t? No, t minus 1. So it was x equals t minus 1, and we're going to set x equal to 0. So this is easy enough, all right? So 0 equals t minus 1, and then how do we solve it? Just add 1. So t equals 1. Now the problem is this is not the y-intercept. This is the value of t when the y-intercept occurs, right? So it's not the y-intercept, it's the value of t when, right? I say when because t is usually a time, right? So it's the value of t when the y-intercept occurs. So what do we have to do? We have to figure out what the y value is at that t value. So that's now our step 2. So we take this t value into the other equation to find the intercept. So our other equation was y equals 2t squared minus 1. Is that what it was? No, 2. I'm always a little bit off, right? So 2t squared minus 2, and I'm going to substitute 1 for t. So it's y equals 2 times 1 squared minus 2. So 1 squared is 1 times 2 is 2 minus 2 is 0. So that y equals 0. So that would be my y-intercept. So what is the y-intercept? We knew x was 0, but y is also 0. And what's usually nice, and I like people to do this, is also give me the t value. So we say the y-intercept is 0, 0 at t equals 1. And that's what I would call my y-intercept, right? But it's still the same basic idea, right? It's still the value of y when x equals 0. And likewise, the x-intercept is going to be the value of x when y equals 0, right? Our definition didn't change. X-intercept means y equals 0. So now we're going to take our y equation, start with that, and we're going to replace y with 0. So 0 equals 2t squared minus 2. Now we'll add 2 to both sides, so we'll have 2t squared equals 2. We'll divide by 2, so we'll get t squared equals 1. And then we'll take the square root, right? So if you take the square root, you'll find that t equals, and remember, and this is still a problem for a lot of people, and it's scary. When you take a square root in an equation, you must take both the positive and negative square root. So the square root of 1 is 1. So it's t equals positive or negative 1. So we're going to have two separate x-intercepts here. One when t equals 1 and one when t equals negative 1. Okay? So now what you will do is you will take these t values and substitute them into the other equation, which in this case is the x equation. And solve for x, right? So take 1 in there, and I get x equals 1 minus 1. So x equals 0. So one x-intercept is going to be 0, 0. And it happens when t equals 1, which shouldn't be surprising because that was the same as our y-intercept from above. right? Because 0, 0 is both an x and a y intercept. And now our other one is going to occur when t equals -1. So we'll plug -1 in here for t, and we'll get -2. So our other x-intercept is going to be -2, 0, and it occurred at t equals -1. Right? And just realize that a lot of people aren't going to ask you for the corresponding t-value, but I just like to do that because I always like to give as much information as I can in these problems. Since it's a parametric equation, why not take advantage of having that extra variable? So instead of giving just the point, right, the xy, also give the t-value where it occurred. So we have two x-intercepts and we have the one y-intercept. So something else that we can do with parametric equations often is turn them into rectangular form, right? And rectangular form is generally the form that we're used to, right? Meaning you're using x and y only in the equation, right? So you're turning this set of parametric equations that actually have t, x, and y, right? They have the parameter plus the x and the y into a single equation that only has x and y, right? So we're going to try to turn the parametric form into a rectangular form. And just as a little aside, there's generally two types of rectangular forms. There's what we call the explicit form, which is usually y equals, like our function notation form. And then there's the implicit form, which is essentially an equation in x and y that's really not solved for y. Okay, so whenever possible, we'll try to turn it into an explicit form, right? The y equals form. All right, so in order to change parametric form into rectangular form, what we have to do is somehow eliminate the parameter t, right? Because then we'll have just an equation that has x and y. So usually what we're going to end up doing in this is use substitution, right? So we're generally going to solve one equation for t and then substitute that expression into the other equation. Now, is that always what you would do? No. But in general, for our purposes, yes, that's what we're going to be doing. So we have our two parametric equations, right, which are x equals t minus 1 and y equals 2t squared minus 2, right? So the first thing we do is we say, well, which one is the one that you would logically solve for t in, right? Well, this one has a t squared, so that gets messy because then when you take the square root, you have to take the positive or the negative. So we'll probably want to use this one to solve for t, which is simple enough, right? It just becomes t equals x plus 1. Right? And this is similar to what you did when you would have a system of equations, right? That's really what this is. It's a system of two equations, and we're just trying to solve it. So we have t equals x plus 1. So now what we'll do is we'll take this expression for t, x plus 1, and we will substitute it into the other equation for t, right? So our y equals equation, right, which is what we want because now we're going to have it in y equals form, right? That's what's called the explicit form, is going to look like this. So it's still 2, but now t gets replaced with x plus 1, and then we square that minus 2. And you might look at this and you might say, well, let's FOIL that now, right? FOIL x plus 1, square it. But realistically, we don't even have to, because look what this is. This is actually our vertex form of a parabola, right? That has its center at -1, -2, and basically is vertically stretched by a factor of 2. And if we go back to what our graph looked like, remember, our graph actually was a parabola. And where was the vertex? At this point here, -1, -2. Right? So it does make sense that this would be the rectangular form. Now, of course, what you lose is you lose the direction of motion, right? Because if I went now and graph this, there would be no, motion associated with it as t increases because there's no t to speak of anymore, right? So the graph would pretty much be identical, um, but there would be no motion associated with it. All right. So usually that's the process that you'll use to convert from parametric form to rectangular form, right? Solve one variable for t, solve one equation for t, and then substitute that expression into the other equation.